Okay, we've done some conversions using the factor label method of units, units of length, units of mass. Now let's look at some units of measurement that are rates, meaning they are a ratio of two measurements. They have a top and a bottom. We might want to convert both of those units in order to get them into a new unit type. So let's look at one rate that we use an awful lot in class, and that is the rate of speed. So for example, here we have 35 kilometers per hour, and we want to convert that speed into meters per second. The speed itself is not changing, it's just being expressed in a different measurement of speed. So we need to convert the kilometers to meters and the hours to seconds. Now, the one thing I would recommend with these is that you really do make sure that you write them like an old-time fraction, a unit on the top and a unit on the bottom. That way you know where your units are and how you can write your conversion factors so that they cancel appropriately. So let's look at what we have to do here. We're going to take 35 kilometers per hour, and that's just really saying that we go 35 kilometers every 1 hour. So the first thing I'm going to do is start with the top. So I'm going to convert the top measurement of 35 kilometers into meters. So just like before with our single unit measurements, kilometers is on the top, so I want a conversion factor with kilometers on the bottom. I want to go to meters as my measurement of length. I know a conversion factor between those two, and I know that I have 1,000 meters in 1 kilometer. So my kilometers cancel out. I'm left with my unit of length as meters. That's where I want to be. I'm done converting the top part of my ratio. Now I need to do the bottom. Right? So I don't know a conversion factor directly from hours to seconds, but I do know a step or a middleman of minutes. Right? So let's use that. Now here what's different and why you want to make sure that you write that distinctly on the bottom. Because when you use your conversion factor now to convert hours to minutes, you have to make sure the numbers are in the right place. Since hours are on the bottom of my rate of my original measurement and I want to get rid of them, in order for them to cancel, they have to be on the top of the conversion factor, and the new unit that I want on the bottom has to go there. So I would go from hours to minutes, and I know that 1 hour is equal to 60 minutes. Now that has canceled out my hours, but now I have meters per minute, not what I want, meters per second. So I'm going to do the same thing with the minutes to the seconds. Minutes on the top, so it cancels out with these minutes on the bottom, and seconds on the bottom, so that becomes my new unit of time on the bottom of my ratio. And once again, 1 minute equals 60 seconds, so my minutes cancel, and I have seconds left over. So when I'm done with my math, I know that my units, if I multiply all the way across the top, are meters. My units, if I multiply all the way across the bottom, are seconds. Now I just have to do the math. So the math becomes 35 times 1,000. I'm going to leave the ones out because you know that anything times 1 is equal to the number, divided by 60 times 60. Here's where you have to watch with your calculator. This is an order of operations problem. Don't get caught in trying to get confused with how you put this into your calculator. If you choose to do it as in this way, you probably should want to put parentheses on the bottom to tell your calculator the correct order of operations so that it does that multiplication on the bottom before it goes ahead and actually divides the top by it. Your other choice is you can stick it into your calculator as a series of divisions, meaning you could do 35 times 100 divided by 60 and then that divided by 60 again. That would give you another way to make sure that the math turned out correctly. But generally, if you just stick with your order of operations and use parentheses whenever you can, you'll be pretty good. All right, so once I do that math, I come out with my answer of 9.7 meters per second. A good way to check is if you're reducing the size of the distance and the size of the time, you should go less in that amount of time, less distance. You're talking about a smaller unit of time, so you should go a smaller distance of measurement. So this number should be smaller than 35, and it is. So it checks out for us. Okay, let's look at another one where we start to introduce some of those measurement conversions between our standard or English system of measurement and our metric system of measurement. Please remember, this is where it gets confusing. M is for meters, so this is a meter. This is a prefix for a meter, which is a kilo, 1,000 meters. When we look at our 3 units of measurement in length and time that all begin with M, we have meters, we have minutes, and we have miles. I would suggest that you always keep M for meters. All right, you would use MIN for minutes. All right, that's for time. And you use the word miles for miles. That way you're never going to get confused as to which unit you are talking about. The only time that you will see miles represented with an M is when it's in this acronym for miles per hour. So whenever you see MPH, that means miles per hour. It's not a meter. So in this case, that means we have to convert the miles to kilometers. And if we look at it, the hours are already in hours, so we don't have to do any time conversion. The only thing we have to do is the distance part of the speed conversion. So when you do this, I would rewrite it as 35 miles, right, per hour. And then you can see what you're already going to have is hours are already in the bottom. You don't have to do any conversion. You have to convert the miles to kilometers. If you look in your conversion chart, you want to go from miles to kilometers. We know that we have 1.609 kilometers for every 1 mile. Our miles cancel out. We get kilometers on top, and we already had hours on the bottom, so we don't have to do any converting there. And that turns out to be 56.3 kilometers per hour. Always make sure you look and see whether or not you actually have to do any conversions for the top and bottom measurements of your rates. Alright, the last one for speed, going from the miles per hour to the meters per second. The common one we use in everyday life to the common one we use in class. So in this case, we're not having it as easy as we did in the last one. We have to take those miles from here into meters, and we have to take those hours from here into seconds. So again, write our given miles per hour. Okay, we can start off with the exact same conversion factor that we did in the last one, going from miles to kilometers, because I know that conversion factor. So 1.609 kilometers per 1 mile. Now that hasn't gotten me to meters yet, but I do know that I have a conversion factor of 1,000 meters equals 1 kilometer. So now if I look at my top, my unit of measurement is a meter. When I'm done doing my calculations, that's what I'll have on the top. But I also have to do the bottom. So the bottom now is just like the first example we did. We're going to go from hours to minutes and then minutes to seconds. So we have hours on top, minutes on the bottom. So 1 hour and 60 minutes. And we have another one to get us from minutes to seconds. And 1 minute is 60 seconds. We go back, our hours, top and bottom cancel out. Our minutes, top and bottom cancel out. We have seconds on the bottom. So when we're done all our math, the arithmetic part, we know that measurement will come out in meters per second. So all we have to do is in our calculator, 35 times 1.609 times 1,000 times 1 times 1. We can leave those out. All divided by the 1 times 1 times 1 times 60 times 60. And when we're all done with that, we get 15.6 meters per second. Hope that helps.